Hey, welcome back. This is episode 16 of the Salesforce Agentforce Masterclass. Today, Agentforce Simulator and Diagnostics Masterclass. How to trace, test, and debug autonomous agents like a Salesforce CTA. Let's get into it. Here's what we're covering today. Introduction to Agentforce Simulator, and the Diagnostic Console, then, deep diving the Atlas Trace View and Intent Classification logs, then, debugging action inputs, outputs, and JSON payloads, then, testing guardrails, Einstein trust layer masking, and jailbreaks, then, automated agent testing using the Apex test framework. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Before launching an autonomous agent to customers, we must peer inside its brain. The Agentforce Simulator and Atlas Trace View allow us to do exactly that, acting as our ultimate debugging command center.
That's a relief. I was worried troubleshooting an AI agent would just be guesswork and hoping for the best. How do we trace its exact thoughts?
Imagine trying to debug an autonomous driverless car by just waiting for it to hit a wall and reading the police report. That is what debugging an AI agent without a simulator feels like. Today, we are cracking open the Agentforce Simulator, your ultimate flight control deck for testing autonomous agents. This isn't just a basic chat window, it is a full-featured state debugger that exposes how the Atlas reasoning engine evaluates user intents. We will explore how to trace the agent's decision-making loops, inspect real-time variable states, and analyze the exact prompts sent to the LLM before they execute. When you type a query into the Agentforce Simulator, you aren't just sending text to a model, you are launching a full transaction context within your Salesforce sandbox. The simulator dynamically gathers user information, active session details, and your current org state to build a secure testing environment. This allows you to simulate distinct user roles and profiles to see exactly how your security settings and sharing rules alter the agent's behavior. Think of it as impersonating an end user while having a heads-up display showing the internal logic of the AI's brain. The crown jewel of the Agentforce Simulator is the Atlas Trace View, which acts like an interactive Chrome Developer Tools panel for generative AI. Instead of guessing why an agent chose a specific flow action, the trace view reveals the step-by-step logic of the planning and routing phases. You can see the classification of the intent, the exact topics evaluated, and the reasoning score assigned to each potential action provider. If your agent is hallucinating or choosing the wrong tool, this is where you can catch the logical mismatch instantly. One of the most common issues in Agentforce development is, when an action is selected correctly, but it fails to execute because of malformed input parameters. The simulator allows you to peel back the curtain on the JSON payloads passed between the Atlas engine and your action providers, such as auto-launched flows or Apex classes. By inspecting the input schema, you can verify if the agent is correctly extracting merge fields from the user conversation. This lets you pinpoint whether a bug lives in your Apex code or in your agent instructions. Building an autonomous agent is as much about defining what it cannot do as what it can do. The simulator is the perfect safe zone to try and break your agent using adversarial prompts, jailbreaking attempts, and out-of-scope inquiries. By attempting to trick your agent into discussing competitor pricing, you can test if your Einstein trust layer and custom guardrails are working. If the simulator successfully blocks the attack, you will see the exact policy or trust rule that triggered the intervention. A conversation is a journey, not a single snapshot, which is why managing session memory is so critical. In this slide, we focus on how the Agentforce Simulator tracks conversational memory and variable persistence across multiple turns of dialogue. If a customer changes their mind halfway through a booking flow, how does the agent update its internal slots? By monitoring the active session state in the debugger, you can ensure that previous inputs are preserved, when appropriate, and cleared out when the user shifts topics. While manual testing in the simulator is fantastic for initial development, enterprise-grade deployments require automated, repeatable testing structures. Did you know you can programmatically test your Agentforce configurations using specialized Apex test classes? By leveraging the Agentforce mock execution frameworks, you can write unit tests that assert on conversational outcomes, routing decisions, and prompt outputs. This ensures that a developer changing a flow or updating a prompt template in a sandbox won't accidentally break your production agent's routing logic. Once your agent is live in production, the testing doesn't stop, it just transitions to real-time monitoring. By linking the diagnostic data from the Agentforce Simulator with event monitoring, and Salesforce event log files, you can build a comprehensive view of your agent's real-world performance. This allows you to track agent errors, action failures, and user frustration metrics at scale. With this continuous feedback loop, you can continuously port real-world failing transcripts back into your simulator to reproduce, debug, and patch your autonomous agents. Alright, let's wrap up. Here are the key things to remember. The Agentforce Simulator provides developer console-style tracing for Atlas Engine reasoning processes. The Atlas Trace view is crucial for diagnosing routing issues, classification errors, and scoring metrics. Debugging action execution requires verifying JSON parameters exchanged between Atlas and action providers. You can write programmatic Apex unit tests to assert on agent routing, enabling robust CI/CD validation. If this helped, hit like, it really helps the channel. Next up, Agentforce for developers, custom LWC components. See you tomorrow.